So one of the first things we'll start talking about, like I stated, are some of those struggles that you guys face in the day-to-day production trying to make cabinet doors. It may look simple, but as we all know, it's not simple. There's a lot of challenges that you guys face. So we're going to primarily focus on the cope and stick construction. So we've got a mortise and a tenon, and that tends to be the most common solution. There are mitered solutions and other types of mortise and tenon, but the cope and stick's pretty well the industrial standard. And really what I want to talk about too is the painted product. Today's market is very much a paint heavy industry. I was speaking with a gentleman last night and he was telling me that his paint it makes up 50 to 60% of his productivity. I know guys that are probably closer to 70. The key is that you really need to have a beautiful joint to make this work. And that's probably part of the biggest struggles that people have is they get this hairline crack that I'm sure you guys have seen. You know, when we're doing stain doors, a lot of that's hidden, especially if it's a darker color. But you do a white or a light color, which is really common, especially on the paint side, and you get this hairline crack. Well, why are we getting the hairline crack? That's really what we need to figure out. One of the most common mistakes I see that a lot of shops made, I did it in my own production. We're always trying to be leaner and leaner and leaner, and we're trying to push production out and get to that next step in the process so that we can get that to our customer and receive payment. Time is money, as they say. So one of the common mistakes people make is they machine it before the glue sets. Most of your glue, depending on what you're using, is maybe a 30-minute set window, maybe it's a 7-minute set time, but regardless, you got to know what that set time is so that you allow it to cure slightly to, as they say, set before you move to the next process, whether that's a sander, whether that's doing your outside edge. You've got to give it that window of time. Otherwise, what happens is you put pressure on that joint, and as soon as you do that, it automatically weakens the joint. So the next area is just general poor construction of the joint. You know, when I started at one of the cabinet shops, we used insert tooling, and for cost savings, we would have our insert tools sharpened. Well, once you sharpen an insert tool or any tool, you start to lose some of the accuracy. Your tenon is a little bit larger, your groove is a little bit smaller, so then you have to spread that. Well, when you spread that, I no longer have a perfectly mated joint. No matter how good or accurate, even shims, it still won't blend correctly. So now I have a poor joint. Or maybe my tenon is too tight and I'm scraping off the glue. Maybe my tenon is too loose and I'm not getting that good mechanical bond from the glue. Another common issue is just poor machining in general. I'm speeding up too fast during the coping process. I'm blowing it out and I'm just wrecking the fibers. And I no longer have a good quality seam. There again, the key to good glue joint is to have a tight fit and it needs to be good, fresh product. And part of that also is timing. So if I cope and stick several doors and then I let them sit for 24, 48 hours, as soon as I cut that, I start losing good adhesion. So getting that built and assembled shortly after machining is really critical to your success. And then the last is inaccurate links. So if I've got a rail that's slightly longer and a bottom rail that's slightly shorter, I'm going to create a gap in that seam. No matter how hard I try, no matter what I do, I will get that joint. And then what happens is you spend all this time puttying in the finish room trying to overcome what was really an inaccurate part. Other things that people are also doing when they have inaccurate parts is it's squareness of doors. And so then they go to extra steps to make sure their doors are square when it was accuracy of the part that was really the common factor. So making sure that square rails, square stiles, exact links on both your stiles and your rails is critical to making a good door and continually to be successful. Some other struggles that you guys are facing outside of just trying to make the joint is your profiles. So it's not uncommon for somebody to have 2, 3, 4, 5. The shop I was at, we had 9 inside profiles. Now, just like everything, 80 to 90% of my productivity was a shaker and a bead. And then I had all these others. But I still have to produce those. And what makes it even harder is when I need to just produce one because something wasn't produced right the first time, or it's something got damaged in the field. And then I've got to do a setup, do a changeover, however that may be in your process. So balancing those profiles, but yet having a good product offering really creates a bottleneck. So one of those solutions that a lot of guys see, and it's very common, is to have either multiple setups or more commonly multiple shapers. So I might have 5, 6, 7, I've seen up to 20 shapers all set up and dedicated. Well, that takes a lot of footprint. And let's be honest, concrete is not cheap, heating is not cheap, and long lengths and floor space require a lot of extra walking and labor that does not benefit you or your customer. It just costs extra money. But on the other hand, if I'm doing setups every time for every profile, I create a whole nother bag of opportunity for failure. Whether I get the right profile, whether I set it correctly, I get my correct dimensions, and just the overall match. So trying to do all that, it's a big balance, and it requires somebody intelligent enough to be able to set those up. And then I have to buy product that's already surfaced 4 sides, or more commonly known as S4S. Another alternative solution is to use a molder. Now, there's some great benefits in that, in the aspect of I get a really good dimensionally accurate part, far better than what I'll get on a shaper. But there again, we're right back to either I inventory product now, or I'm doing multiple setups. Inventorying product, like we just talked about previously, it affects the quality of the glue joint. As soon as I mold it, I machine it, those open pores in the wood are already starting to close. So I don't want a whole lot of inventory, otherwise I'm going to have bad product. On the other hand, I've got to have enough inventory that I can utilize that to stay product. I don't want to tear down my molder every time I need to do a changeover. So there again, we face some of those struggles. Yield is another thing that a lot of people don't think about. And so if I've got a 8-foot board and I have a knot at 3 foot on the face and a knot at 5 foot on the back, once I mold it, I have to cut out that knot on the face because my customer wants a clean product. But I could have gotten by with that knot on the back. Well, if I use S4S, I can now flip those boards, excuse me, and that allows us to be able to save some yield. I can also compensate for anything that might have curvature, bow, twist, and I can orientate that appropriately. Another issue is blowout. Once I've had a molded profile, I've either got to have a reverse backer block so that I don't get blowout on the inside coat or inside profile, or I have to have a counterclockwise and a clockwise rotation on my equipment. So what all of this really comes down to is the setup time, getting it done right, more importantly, getting it done right the first time. And somebody very wise once told me, rework costs 3 times. It costs the time that you built it wrong, the time that you built it right, and lastly, the time that you should have been building something else that you got paid for. Looking at that along with the warranty issues and customer dissatisfaction, it's very important to make sure that you're able to get these products done and done right. So let's start talking about some potential solutions. So the solution we're going to focus on is our Vitongen kitchen work cell. It consists of 2 pieces of equipment, a profiler and a tenoner. So we'll walk through each of these and how they function, and then we'll start talking about what benefits and how they are to solve your door issues. So first and foremost, both of them are a CNC machine. We've got a controller on board where you can store all of your profiles so that you no longer have to have an operator to go over there and change it every time. The machine moves everything into position, making things quick, easy, fast, and accurate. Most importantly, it allows you to have a batch size 1. So let's dive in to the Pentho. The Pentho is a single end tenoner. And as you watch here, we've got a trimming saw. So now I'm able to size my part. I'm also profiling, and I'm able to wear stacking tools. So I can have up to 9 tools, depending on how you put things, 9 different profiles. I'm cutting 2 pieces at the same time. So I'm going to take my rails for the door or my stiles for the door, and I'm going to size those to length. And on my rails, I'm going to cope and size. So I get a perfectly accurate product. Both my rails are matched, both my stiles are matched. And then I'm easily able to change from one program to the next, adjusting the fence and moving back and forth. Also, if you watch as this table moves, you'll see that it speeds up as it's transitioning to the saw, and then it slows down upon entry. This allows for a much better joint, allowing for, there again, it's all about getting a good glue quality joint. So just kind of a review. First of all, we've got an automatic table. Benefit of that is I'm not worried about the operator going too fast, too slow, getting a poor quality of cut, and possibly damaging the wood. I've got the adaptive speed so that it's accelerating during non-cutting times and decelerating when it's cutting so that you get precision product. I've got a pneumatic clamp that allows me to work with 2 pieces so that I get a matched pair. And I'm coping after sizing, so I get a perfectly good, accurate part. I don't have to now have accurate links. I can use a inaccurate chop saw now and produce highly accurate doors because I'm doing the dimensioning while I'm coping or just sizing a style. And because we're also, if you watch the video, that cutter head jumps in and out, allowing me to have a single pass cut. A lot of other solutions out there, you actually run your part through the process twice. That's dulling your tools, and there again, potential issues for accuracy. As you can see here in the video, we're able to hold both parts, secure them, keep our hands out of the way, maintain safety, and as you'll see this jumping in and out, now the cutter head engages as we come back, and we're able to size your profile, and we get a beautiful quality of cut. So it's simple, it's easy, and it's accurate. So now let's talk about the Profil. The Profil is basically a single-sided molder. We have an outboard fence, as you can see on the left, so now we're able to size it. And we're also able to use a feeding device that is a top pressure belt that's solid. So I'm able to do very small length of parts and have highly accurate control. And I can do, there again, batch size 1, 1 door at a time, maintaining a constant productivity. So we've got the side pressures, top main belt, side fence. We also have a steel table with a cutout. So if you look in this picture on the left, I'm able to maintain complete control of the part except for where it's cutting. That way I have complete support. I also, on the right, you can see, I've got a belt on the infeed and the outfeed that helps get the part to the feed belt and away from the feed belt, allowing my operator much ease of use without having to stand there and secure the part the whole time. Program changes are also very simple. With a simple touchscreen interface, I can make a change in length, and like we talked about, with small parts, I'm capable of doing down to 4 inches in length, 1.5 inches in width, and up to 100 inches in length and 9 inches in width on both machining cells. So I am able to capture 80, 90, maybe 95% of your productivity on one machine. And there's value in that, where I have one guy who can produce doors all by himself and get one door at a time production, batch size one, without having to do additional manipulation. Simple, easy, effective. And that's what makes it work. So let's review again. 4 inches to 100 inches in length, sized correctly. Width of 1.5 to 9 inches, sized correctly. There again, as we watch the video here, we're able to make simple changes. And like we discussed, I've got 300 millimeters of spindle height. That allows me about 9 tools. So 9 tools, 1 machine, no changeovers, no setups, no manipulation. 1 door at a time, next door, next door, next door. Simple, easy. So we're talking a 20-second changeover to go from one profile to another. CNC positioned, single cell operation. I would actually highly recommend that you have one person running the front end of the machine, and then there'll be a person catching on the backside. And that person, since he's getting the 4 parts for the next door he needs, is building the door right afterwards. So now I have 2 people building doors, and I can be anywhere from 400, 300, 400 doors, maybe even up. And we've seen this before where customers are able to get up to 900 doors in a shift. We also have barcoding capability. So if you don't want your operator to have to do any interfacing with the screen, now you can scan the barcode. That barcode references a unique ID number, and then it'll automatically position the length and the profile while it's keeping track of what's been done and what's still left to do for your job, making it very seamlessly easy. So now let's kind of review what this solves. And whether it's this machine or implementing some things in your own field, at least you can gain some of that knowledge base. So starting with S4S allows you to gain your yield. I can alter my board. I can put the bow in the correct direction. I can put knots that are acceptable on the back versus having to cut out a knot that could have gone if it was already pre-molded. I don't have to have a super accurate saw. So I can either go with a saw that's faster or maybe lower cost. Either way, I'm going to do the sizing on the machine. Parts are perfectly square, perfectly accurate because I'm cutting 2 parts at the same time and I'm going through that sizing process. All of that put together reduces your rework. That makes your productivity way, way faster. I'm able to capture their small parts with my operator being safe and distance from any danger. Also, no inventory. I don't have to have a stack of moldings waiting for somebody just to order that profile. They're again causing potential joint issues. Like we talked about, accurate. I'm not worried about how accurate my saw is because we're going to size it. No matter what the sizes are, short parts, we're able to run, and that 4 inches is including the tenon. So you're really looking at, in this case, a 3.5 inch part that we're able to successfully feed. That's crazy, guys. There's nothing out there that's able to do that. This gives us that perfect joint that we want so that we can paint our product and not have to have additional people sitting there working, puttying in a finish shop to overcome a joint issue. We're not have to worry about square doors because our doors are accurate and already square. Also, this allows you to be able to machine MDF successfully without any alteration. It's the same machine, the same setups, the same tools. Also, something that we didn't discuss is not only are these large amounts of tools, but I also have a 200 millimeter to 220 millimeter diameter cutting circle. That means my rim speed is so much faster that the quality of cut coming off of this machine is just perfectly flawless. So batch size 1, simple, easy. Within 45 seconds, I can be producing a different door. Boom, boom, boom. One after one after one. Nearly 1 door a minute. I've actually been able to do this up myself personally operating it. I can get about 30 seconds to process a door. Now, that's not realistic every day, all day long, but for sure, 1 door a minute or less is very feasible.